Hey guys, today we will learn about the reasons to take a conjugate, on the complex number for current, not voltage, when we calculate the complex power. Let's see. So, let's move on I will try to draw. First of all, you guys need to know is our voltage system is when we using the daytime lagging, right? I is lagging. So this is remember, because in the daytime we use lots of powers, right? So this is a general situation in the power system when it, drawing the pager. So first of all, there's the question was why I or no between them. What's the differences? I will be casting you guys. You generally see this, right? But you don't know why we use it this, conjugate on the current, not the voltage. Because our, general system is lagging. That's why we use this. But actually, the result is the same. But, how to, interpret the page is a little bit different. Because we are lagging system generally. So we need to, we prefer to interpret in the lagging, way. But this is a leading way. So different way, just a reverse is what I mean. Reverse the situation is. So look at that. If I see the for example, if you guys don't see, I mean, I'm not sure you guys can see this English English word. We could see lead this way from this side, upside, underside. But like this, if it's like that, we could read it, right? We could read it, but a little bit weird, right? So that's the only difference. That's what I wanted to say. So first of all, I will try to do it. So look at that. Yeah, alpha 1 and I is alpha 2. So first of all, we need to draw is here. Here's V1, no, V, and here's the alpha 1, I will say. And this is I, is alpha 2. And this between Vi is, we will say, zeta, right? So what I want to say is here, Vi conjugate here, right? So actually it could be P plus JQ, right? Real power and reactive power, right? So if we do it Vi cosine, no, Vi alpha 1 plus alpha 2, right? The zeta. But look at that. If we change it to is here, this one to this one. So Vi cosine alpha 1 plus alpha 2 plus J Vi sine alpha 1 plus alpha 2. But look at that here, guys. Here. Alpha 1 is from 0 to the voltage, right? Here. But if we add these two numbers, it doesn't make this zeta, right? So that's why we needed to conjugate I. So I will show first where if we conjugate I part. So which means if we conjugate I part is gonna be minus in the angle part. So which means it changes to the plus here, this part minus, and this part minus. Don't worry, okay? I will explain one more time. So which means Vi cosine theta now plus j v I sine theta. Why? We conjugate on the current, right? So that's why current part's angle is this. Alpha 2 is minus. You know, right? If it's we conjugate here v part, voltage part, the alpha 1 is minus. You know what I mean? So now we can see this number, right? So like here's q and minus q, here's p q. This is lagging how we lead. You know what I mean? And then you can see this here plus. Plus means if it's a motor, it spend the reactive power, consuming. And if it's a generator part, we say I supply. Plus is meaning. You know what I mean? This plus. If it's minus, it needs to change it, which means a reverse way we say it. So for example, if it's minus here, we say motor is giving to them, like it's gotta be generator, not consuming motor, right? Reverse. And the generator, if it's minus, which means we say it's kind of consuming reactive power. So which means it gotta be kind of motor. You know what I mean? So that's why we needed like a plus, like we prefer here this part. But if we did here conjugate vi, what happened? Look at that. So vi cosine, what is that? I said here is minus, right? So minus alpha 1 plus alpha 2 plus jx jvi cosine sine minus alpha 1 plus alpha 2, right? So if we could change it minus alpha 1 minus alpha 2, then also this plus j vi sine minus alpha 1 minus alpha 2, right? This is theta, right? So which means vi cosine minus theta plus j vi sine, minus theta. So cosine is gonna be also same, vi cosine plus, no, cosine is gonna be a change, but theta is cannot be, it's changed, so which means minus j vi sine theta. You guys can see here minus. That's only differences. You know what I mean? So which means if we draw here, here's minus. We draw like this. Yeah. Minus here. This part is kind of math part. You don't need to remember, you know what I mean? Just there's something like this. Why we use it? Because if we, the result is important. If we conjugate v, we interpret back here, both sides. But if we, conjugate current this side, you know what I mean? The only differences. So what happened here is how we, interpret this. Minus means, I said reverse, change the meaning. So if it's a motor, what happened? Oh, minus, which means it provide, right? Not consuming, reverse. and generate. It need to actually supply, right? But it's consuming. You know what I mean? Motor is a supply, like a generator. Levers, you know what I mean? The result is the same. But I mean is the interpret is it could be depends on the person, how they draw this page. But we prefer because we prefer this because our power system is lagging system generally, right? Data. Yeah, that's it. Today's lecture, guys. Oh, and I didn't see you guys here. Here is lagging, right? If we conjugate I, but what is that here? If we conjugate here, I said it changed here, minus, right? So you don't need to this, math part. Just you guys can remember this fine, like the result. You know what I mean? Yeah, that's right.